In this video, we'll be finding limits graphically. Now, the notation that you'll be seeing is this notation right here. And the way you read that is the limit of f of x as x approaches c. The problem that we'll be working with is we'll let f of x equal this function, x cubed minus 1 divided by x minus 1, all of that minus 1. And we're asked to find the limit of f of x as x approaches 1. Now if we tried direct substitution, we would see that we'd have division by 0, because if you put a 1 in here for x, you get 1 minus 1, which is 0 in the denominator. And we know that division by 0 is undefined. So we have to approach this problem differently. So let's find that limit graphically. I'm going to first do it on the graphing calculator, and then we'll look at it graphing by hand. We have the quantity x cubed minus 1 divided by the quantity x minus 1, and then minus 1. So we can see that this is our graph. It looks like a parabola. If we did a trace and approached x equal 1, keep an eye out right here. We want to get close to x equal 1. We can see that when x is less than 1, we have about 1.6. When x is more than 1, we have a little more than 2. So I'm thinking that the limit is going to be 2. Now the way that we can get a little bit more accuracy with our graph, if we do zoom and then decimal, which is choice 4, we can see our hole at x equal 1. So it becomes more obvious when we have the discrete x values. Let's look at graphing this by hand. What we'll have to do is, we can see that this is the difference of cubes. So let's write that as the factored form. So it'd be x minus 1, and then the trinomial x squared plus x plus 1 over, and then we have x minus 1 in the denominator, and then minus 1 out here to the side. So that discontinuity, that whole, is going to cancel off, and I'll have x squared plus x plus 1, and then minus 1, and the plus 1 and the minus 1 cancel, and I have just x squared plus x. Now to graph this easily, we can factor out our x, and we'll have x plus 1. So we can see then that I'll have zeros at 0 and at negative 1, because when you put negative 1 in here, you'll get a 0. Our graph then is going to look like this. And our question is, what happens when x equals 1? Well, if I sub in x equal 1, we have 1 times 1 plus 1. So 1 times 2, which is 2. So our question was, what is the limit of f of x as x approaches 1, if we get rid of our discontinuity by factoring and canceling off that x minus 1 that's in the denominator, then I no longer have a problem with division by 0, and I can use direct substitution. So my limit as x approaches 1 of f of x is 2. So our graph for this function, we had a hole at x equal 1, so the hole was right here. So the graph as we approach, as x approaches 1, comes in toward that value. So from the left and from the right, as x approaches 1, this is 1, my y value approaches 2.